Welcome back to math. These are the practice problems for section 19 on systems of equations and inequalities. First we'll graph this inequality, and we're asked to show whether or not the point 1, 1 is part of the solution set. So this is in the standard slope-intercept format, so we can graph it similarly to how we would graph a linear equation. The intercept on the y-axis is at -1, that would be here, and it's got a slope of 2. That's rise over run, so 2 over 1, up 2 over 1, up 2 over 1, or down 2 backwards 1. This, however, is a less than sign, and it does not include the equal to option, so we have to make a dashed line here. And then, which side of the line do we shade? So these are the y values that are less than. So it should be this part of the graph that gets shaded. Let's test point 1, 1, which looks like it's right on the line. So we'll substitute 1 and 1 for x and y. So instead of y less than 2x minus 1, we'll have 1 less than 2 times 1 minus 1. 1 less than 2 minus 1, that's 1. And it's not true that 1 is less than 1. So no, that point is not part of the solution. Let's test this point here, though, to be sure we've shaded the right side of the equation of the line. That would be the point 2, 0. So we'll substitute in 0 for y and 2 for x. And yes, that's true. 0 is less than 3. So in fact, all the points on this side of the line are part of the solution. This is problem 2, and we've got two equations, a system of equations, and we're going to solve using graphing, and then we'll solve with elimination and substitution. So let's start with the graph, and these are in the standard format. So for this one, the y-intercept is at -4, and we've got a slope of -2. That would be down 2 over 1, or up 2 backwards 1, up 2 backwards 1. So the line looks like it's going about like this. And for this one, the intercept is at 5, and it has a slope of 1. So So it looks like the intersection is right here at this point, which would be an x value of -3 and a y value of 2. So now continuing on with that problem, let's solve this first by substitution. Both of these equations are in terms of y, or solved for y in terms of x, so we can actually set the two of them equal. If y equals this and y equals that, then this must equal that, right? So -2x minus 4 equals x plus 5. We can start by adding 2x to both sides. That would give us 3x here. And then we can subtract 5 from both sides. And we get 3x equals -9. Divide by 3, and we'll get x equals -3. We still have to solve for y, but we know that y equals x plus 5. So using this value for our 5, y equals -3 plus 5, so y equals 2. And again, we have the same solution we did before of -3 for the x and 2 for y. Alright, now with elimination, since both of the coefficients here are 1, we can actually go right ahead and we're going to subtract so that we can eliminate y. Y minus y is 0. We have to do the same thing to all the terms. They're lined up correctly. -2x minus another x is -3x. -4 minus 5 is -9, -9. Well, add 9 to both sides. 9 equals negative 3x. And divide by negative 3, x equals negative 3. And again, now we'll substitute negative 3 for x. Y equals 2. So again, same solution. It's negative 3, 2 is our solution set. Practice problem 3 has two equations here, and they would like us to solve that with elimination. And that's a great solution, or a great method to use, because both of the x coefficients are 5. So if we subtract this equation from that equation, it will eliminate the 5x's. In other words, 5x minus 5x is 0. Now let's do the same thing with the y terms and the numeric terms. 3y minus 4y is negative y, or negative 1y. 3 minus 8 is negative 5. So negative y equals negative 5. Divide both sides by negative 1. That gives us y equals 5. So if y equals 5, I'm going to take one of the original equations, and we'll put 5 in for y. Now we have 15 equals 5x plus 3, subtracting 3 from both sides, and dividing by 5. This fraction would simplify as 2 2/5. So the answer is 2 2/5 for a value of x, and y is 5. And that's a good example of why we use this instead of a graphing method, because even on a graph it would be really hard to tell 2 2/5. Problem number 4, we're given two equations, and we are asked to solve that with substitution. Well, neither one of these is solved in terms of x or y, but this is close. It's 2y, and all of these terms are divisible by 2. So that's a good one to divide all the terms by 2, and we'll get y equals negative 2x plus 3. That's this equation with all the terms divided by 2. Now, if we know that y is negative 2x plus 3, we can substitute that in here instead of y. Negative 2x plus 3 plus 6 equals 4x. Now distribute. That's negative 10x plus 15 plus 6 equals 4x. We'll add 10x to both sides to get that there, and 15 plus 6 is 21. So dividing by 14, that's 21 divided by 14, and of course that would simplify. They're both divisible by 7. Dividing the top and the bottom would give us 3/2 for x. So now we need to solve for y. Y equals negative 2x plus 3. I'm still taking that version of the equation. Y equals negative 2 times 3/2 plus 3. Y equals, now this is, the 2's cancel out, but the negative remains, so that's negative 3 plus 3. So y equals 0. So the answer is going to be our x value, 3/2 and 0. Problem number 5 says the sum of two numbers is 36. If the larger number is 3 times the smaller number, what are the two numbers? So here's a word problem where we can use a system of equations to solve. So we're going to use x as one of the numbers and y as the other one. And so the sum of two numbers, that would be x plus y, equals 36. That's one equation. If the larger number is 3 times the smaller number, what are the two numbers? So it doesn't matter which one of these really is the larger or the smaller, but we know that 3x, for example, equals y. So that means we know what y is. We can use substitution here. So if x plus y equals 36, and x plus 3x equals 36, then 4x equals 36, and dividing both sides by 4 gives us x equals 9. Alright, so if x equals 9, y is 3x, so y must equal 27, or 9 times 3. And yes, in fact, when we add those together, 9 and 27, we will get 36. So our answer is 9 and 27.